How much area is the shaded region in squares? Okay, so we're trying to figure out exactly how many squares in the shaded region. This is a difficult shape. It's hard to figure out. So what I'm going to do is, instead of trying to find out the shaded region, I'm going to do step 1, find the blank area, the area missing. Oops, that is not what I meant to do. Find the blank area. That's missing. So that's easier, and then we'll subtract from the total to find the shaded. So here we go. So here's one square that's missing blank area. One square there. Let's go down here. I'll start with what's easy. Okay, what's easy is over. So I got those 4 squares. So what else? Well, I can do this triangle here. This is a triangle, isn't it? Right, this triangle here. So this is a triangle, which is a half base times height. That's a half. This side is 2. This side is 1, right? A half times 1 times 2, which is 1. It's a 2 by 1 triangle. So, oops. So this, therefore, this will be 1 also. It's a triangle. Same thing here. See this right here? Triangle. Triangle. A half base times height. It's a half of 2 times 1. Half of 2 is 1. So the area of that is 1 because it's a 2 by 1 triangle. Same thing over here. Look at this big triangle here. This is a triangle right here. Triangle. Half a base times height. This thing is, what is it? 1, 2, 3 tall, and its base is 1. So 1 half of 3 times 1, half of 3, 1.5. So this must be 1.5. Up here, another triangle. Which is a half times base times height. Again, this one's a half of the base is 1. The height is 2. Half of 2 is 1. So this is also 1. Okay, we've got almost all the missing area. Now the hardest part, the last part, the most difficult part beyond debate for sure, the most difficult part is this weird looking shape right here. Now what is that? Well, it's a triangle, isn't it? It's a triangle. Here, let me move this over a little bit. It's a triangle. And the area of a triangle is a half times base times height. That we know. The area of a triangle is a half times base times height. Okay, now what's the base? Well, the base right here is 1, clearly, isn't it? But what's the height? What's the height? Now you might say, I don't know the height. I don't know, I don't know how long this is. Is that the height? Or maybe this one's the height. Which one of those is the height? And we don't know how long those are, do we? The answer is, this is important, this is the most important part of this problem. Make sure you catch this. Neither of those is the height. That's not the height. Remember, height has to be at 90 degrees to the base. So, for example, let me back up here. If we have a person, oops, I'm drawing with the wrong thing here. So if we have a person, and we want to measure their height, we go from the top of their head straight down to the ground, don't we? We can't go down diagonally. That's not height, right? No diagonal. See, oh yeah, okay. But what if they lay on their side? They're laying on a bed or something, and we want to measure their height. How do we do it? Well, same thing. From the tip of their head to the base of their feet. Again, we still can't go diagonally. That's not height. So this triangle is laying on its side. Here's its base. So its height must be from right here at its very top straight down. Straight down to the ground, right? That must be the height of the triangle. See, because here's the base over here, so that's at 90 degrees to the base, right? I hope the leaning part isn't confusing you. What if you had some kind of weird leaning triangle? And somebody said, what's the, and here it is on the ground, what's the height? You know what you would do. You would go, the height would be right there. Here's the base, here's the height. Right? The height has to go from the tip top straight down to the ground. Even if that doesn't touch the base, that's still the ground on which the base sits. Well, this is the same thing. This triangle here is just sitting sideways. So its area, base is 1, height is what? 3. This is 3. The height is 3 here. Right? 1, 2, 3. That's its height. So if that's the case, let me back this up a little bit. Okay, so if the height is 3, so it's 1/2, 1/2 of base times height. It's 1/2 times 1 times 3. Half of 3, 1.5. So this must be 1.5. That missing area, that triangle area. Okay, so now we got a lot of missing triangle area. So what is the total missing or blank area? What is it? Well, let's add it up. 1, 1, 1, 1, 1, 1. That's 6, 1. Oh, and 7. So 7 plus, right? I just added up 7 of those ones. And then 1.5 and 1.5. So that's 10. So the total missing area is 10. So the shaded area, the shaded must be total area minus missing area. Or blank area. Right? So what's the total area in this entire shape? So we go like, down to here and over to there and up to here and this entire rectangle. What's the area of this entire rectangle? Well, it's a 4x4 rectangle, isn't it? It's 4 this way, 4 that way. 4 wide, 4 tall. It's a 4x4 rectangle. So the total area, so the shaded area, then is going to be total area 4x4 minus the missing blank area, which I already decided is 10. So that's 16 minus 10. So the shaded area is 16 minus 10 must be 6. The shaded area must be 6. All the shaded area, everything shaded. I don't want to just put it here, make you think it's all the shaded area, because I took the total area that's present, which is 16, 4x4 rectangle, and subtracted all the blank areas, all the missing areas that we added up, which added up to 10. So the shaded area is 6. That's a hard one.